Hey, what's up everybody? Chris here with another tech tip video, and for today, I want to talk about strategies around reducing weight when working with sheet metal or CNC machine parts or enclosures. So let's just get right into it. Reducing weight is more than just an engineering challenge, it's a necessity for product developers looking to improve product functionality, boost energy efficiency, and reduce overall product costs. So for today's video, we're going to explore effective weight reduction strategies for parts and enclosures manufactured by either sheet metal fabrication or CNC machining, and then outline the advantages and challenges of each. But first, why does weight reduction matter? Well, lightweight designs are crucial for modern products. Whether you're developing simple electronics housings or advanced aerospace components, reducing weight means enhancing overall performance. So here are some quick key benefits of weight reduction in parts and enclosures. Reduced material usage and lower cost. Lightweight designs are typically used to minimize unnecessary bulk of material. By optimizing your design and using materials like aluminum or high-performance plastics, we can achieve the same strength and durability with less raw material, leading to lower material costs. Ergonomic considerations. Lightweight designs are easier to handle during assembly and usage. We have an entire video focused on tips for designing portable parts and enclosures, so we encourage you to check that out. The link is going to be in the description below. Easier installation and maintenance. Lighter enclosures are easier to handle during installation and maintenance, reducing the risk of accidents or injuries. Better thermal management. Lightweight materials often have better thermal conductivity, resulting in improved heat dissipation and temperature regulation within the enclosure. Now, for a compare and contrast on our two manufacturing processes offered here at Protocase and Protospace MFG, sheet metal fabrication and CNC machining, we recently produced a video that helps you understand which process to use when manufacturing prototypes for your projects. That video will be linked in the description below. Now, given the distinct characteristics for each manufacturing process, the weight reduction strategies will also differ significantly. So let's take a look at the design strategies for each. Now, starting off with sheet metal, choosing the right material is going to be the first and most impactful step in reducing weight. When choosing between aluminum, stainless steel, galvanneal, and cold-rolled steel for weight reduction in sheet metal designs, aluminum often stands out as the best choice. Aluminum is significantly lighter than the other materials while still offering excellent strength-to-weight ratio and corrosion resistance. However, the suitability of aluminum also depends on specific operational requirements, including any environmental exposure and mechanical stress. So if higher strength or enhanced durability is required alongside this weight reduction, then stainless steel or galvanneal may be viable alternatives, albeit they will be slightly heavier. Secondly, optimizing your design before manufacturing is going to be important. Be sure to design your parts and enclosures with minimal material usage. This can include strategies such as redistributing the material where strength is most needed. Here are a few strategies when you're in the design phase. Incorporate cutouts in low-stress areas to eliminate unnecessary material. And utilize SolidWorks features. You're going to want to leverage SolidWorks' built-in sheet metal tools to accurately design and modify parts and enclosures. Apply features like flanges, hems, and jogs to add strength without significantly increasing the weight. Lastly, for sheet metal, you'll want to focus on incorporating alternative fastening methods. Traditional fasteners like screws and bolts add unnecessary weight and require additional material for reinforcement. Instead, techniques such as welding or adding rivets can be incorporated to create secure joints with minimal added mass. Now, for CNC machine parts and enclosures, there are a few different strategies that you'll want to keep in mind when looking to reduce the weight of your design there. So first, and not surprisingly foremost, is to think about your material choice. Aluminum is often the top choice for reducing weight due to its excellent strength-to-weight ratio, corrosion resistance, and ease of machining. Steel, while heavier than aluminum, does offer superior durability, cost efficiency, and can be ideal for applications requiring added strength over reducing weight. And stainless steel provides exceptional corrosion resistance and a polished finish, making it suitable for environments with high moisture or demanding aesthetic standards. Ultimately, the decision hinges on the balance of weight, cost and durability, and of course the environmental factors of the intended use case. Secondly, think about utilizing hollowing when designing CNC machine enclosures. Hollowing out non-structural areas inside your enclosure can be one of the most effective ways to reduce the weight of a CNC machine enclosure. Creating pockets and other features in your design can remove wasted material without compromising the structural integrity of the enclosure. Lastly, you're going to want to think about adding support structures inside your design. One common method for increasing the durability of an enclosure is to increase the bulk or mass of it. Instead of increasing the bulk or strength, consider adding support structures to key load-bearing areas. These features provide rigidity without unnecessary weight addition. Perform simulations inside your CAD program to identify regions of high stress and strategically place reinforcements where needed, avoiding unnecessary support that would add weight. So mastering weight reduction in sheet metal and CNC machine parts and enclosures will require a balance of material science, innovative design principles, and a manufacturing process that is powered by HVMC. Now at Protocase and Protospace MFG, we move scientists and engineers past the job shop model with high-velocity mass customization, the most major technical innovation in custom manufacturing since the introduction of 3D printing. By blending quality and speed, HVMC makes custom parts at the highest velocity possible. It's the full spectrum mass customization that you need to get your project done as quickly as possible. So if you do have any questions, please send them in the comments below or head on over to either website and send a message to one of our account managers who are always ready and available to help. If you did enjoy this video, please like and subscribe so you don't miss out on any future tech tips. Until next time, please take care.